Hi. You've dialed into the NOAA Office of Oceanic and Atmospheric Research Social Science Network webinar. We're going to be getting started in about a minute or two, and so just hang on. We'll be with you shortly. Hi, welcome to today's webinar. This is part of the NOAA Office of Oceanic and Atmospheric Research Social Science Network webinar series. Today's session is on vulnerability assessments. Just so you know, in the room with me is Elizabeth Roaring. She's from Sea Grant, and I'm Nancy Beller-Sims from the Office of, I'm sorry, getting this other program office. Yes, excuse me. I had my first grandchild early this morning, and I'm on a high. So today we have two speakers, and we're really excited about our speakers. They both come from the RISAs. What we're going to do today is I'll introduce each one separately. They'll speak for about 20 minutes, and then we'll switch, and the second one will speak for 20 minutes. You can see on the side panel that you can ask questions. So type your questions into those boxes, and we'll take the questions at the end. If it's something that's a clarifying question, we may ask the speaker, we may not. We're looking forward to it. So let's go ahead and get started. Our first speaker will be Jenna Jordan. She's from the University of Michigan. She's a program manager for the Great Lakes Integrated Sciences and Assessments, or GLISA, at the University of Michigan. She provides day-to-day leadership and administration of GLISA operations, staff, and students, and also coordinates faculty research at the University of Michigan and Michigan State University. She also serves as the primary point of contact for the program and represents GLISA at local, regional, and national meetings and events. Before joining GLISA in January 2017, Dr. Jordan worked as a policy associate with the Climate Registry in Los Angeles to maintain existing and develop new greenhouse gas accounting policies. He previously worked to improve energy efficiency and clean energy initiatives in Los Angeles with Global Green USA. He has a Ph.D. in geosciences from Princeton University and a B.S. in biochemistry from the University of Illinois at Urbana-Champaign. Okay, Jenna, it's all yours.
Great. Thank you very much for that introduction. I will go ahead and get started. Again, good afternoon. I'm Jenna Jorns with the Great Lakes Integrated Sciences and Assessments, or GLISA, and I'm pleased to have the opportunity today to present a product that GLISA developed in collaboration with several partners, the Climate Ready Infrastructure and Strategic Sites Protocol, or CRISP for short. So I'll start with a quick summary of GLISA's approach before giving an overview of the project. Then I'll explain the outcomes and some lessons learned, as well as how the product has informed decision-making and how it may be applied to broader areas. So first, I'll briefly give some background on the NOAA program that we are a part of, just in case this is new information for you. So NOAA's Regional Integrated Sciences and Assessments, or RISA program, is housed in NOAA's Climate Program Office. And since the 90s, the program has supported regional research teams that help expand and build the nation's capacity to prepare for and adapt to climate variability and change. GLISA is proudly one of these 10 currently funded RISA teams that you can see here on the map. And we are the dark blue, kind of teal team in the Great Lakes region. So we were established in 2009, and we cover the 8 Great Lakes states and the province of Ontario. And while we've worked in a number of sectors, our primary current focus is in 3 areas: cities, tribes, and agriculture. We are a partnership between the University of Michigan, where we sit at the School for Environment and Sustainability, and Michigan State University at the Center for Global Change and Earth Observations. So GLISA's overall goal is to facilitate informed decision-making in the Great Lakes using the best available climate science. So in addition to working to understanding the impacts of climate change in the region and providing climate projections to our stakeholders, we use social science to understand how this information is being communicated and used so we can improve the credibility and efficiency of this process. Each year we hold an annual competition to award small grants to boundary organizations. And these are partner organizations that serve as facilitators or brokers between the climate information that is produced at the universities, so the GLISA produces, and the stakeholders that use it. So for this project, decision makers and cities. As shown in the schematic on the slide, these boundary organizations and the chains that they form reduce transaction costs through the sharing of resources and leveraging existing trust. So using this model and the small grants program, GLISA has provided technical and fiscal support to 20 partners in our first 5 years, extending our reach to more than 50 additional entities. Our funded partners include agricultural extension professionals, land managers, municipalities, watershed councils, and researchers, just to give you a flavor. The results of these projects inform the next year's competition, as well as our internal research priorities. And the project I'm presenting today is an example of this boundary chain model, where GLISA teamed with 2 boundary organizations to reach decision makers in 5 cities. Okay, so on to the Climate Ready Infrastructure and Strategic Sites Protocol. The CRIS project was funded through one of these small grants in 2014, awarded to the Great Lakes and St. Lawrence Cities Initiative, which I'll just refer to as the Cities Initiative. They are a binational coalition of 131 U.S. and Canadian mayors working to advance the protection of the Great Lakes and the St. Lawrence River. And one of their focus areas is climate change adaptation. The Cities Initiative were the project leader, and collaborators included AECOM, a multinational engineering firm that works in climate change impacts, risks, and adaptation, and the city of Gary, Indiana. So municipalities in the Great Lakes region are already experiencing the effects of climate change, from flooding to extreme temperatures, winter storms, and high winds. But most small and mid-sized cities in the region don't have the resources to assess their vulnerable infrastructure for extreme weather events. Another challenge is finding the appropriate climate information and their projected impacts at a local level. So the project was designed to address both of these challenges. Gary, Indiana is a mid-sized coastal city on Lake Michigan with significant coastal development and assets, as well as a history of vulnerability to extreme storm events. It is highly urbanized and has a proud industrial past in the steel industry. But this legacy also includes a presence of industrial waste, 5 EPA Superfund sites, and aging and abandoned infrastructure. They had a very engaged municipal staff that was willing to partner with us on this project, motivated in part by a catastrophic flooding event experienced in 2008. A 100-year storm got the attention and buy-in from city leadership, and the storm resulted in a major stretch of interstate highway, 8094 for those familiar with the region, being closed for more than 1 week, and a major university being closed for 2 weeks, among other damage. So the purpose of the project was to develop a simple, expedited vulnerability assessment tool that small and mid-sized cities could use to assess the vulnerability of their infrastructure to climate change and extreme weather. The key goal was to ensure that the tool relied on existing data, municipal staff's own knowledge of their facilities, and existing city planning processes, so not adding a new requirement for data or a new effort to sustain. In addition to Gary, Indiana, serving as the lead pilot city, 4 additional cities were on an advisory board and also piloted the protocol. These included Evanston, Illinois, Milwaukee, Wisconsin, Niagara Falls, Ontario, and Traverse City, Michigan. And in addition to providing funding, GLISA's role was to provide access to climate and weather data, coordinate additional data collection, and contribute to the decision matrix and white paper that I'll talk about in just a minute. So this was a one-year project and was originally designed to first develop the tool with the 5 cities and then pilot it with real sites of concern in each city. However, in the first month of the project, all partners agreed that it would be more efficient for Gary to conduct the pilot simultaneously as the tool was developed. This allowed us to learn sooner what data cities actually have available and what assets are of interest to assess, and to test applying this information in a real situation but before developing the more detailed elements of the protocol. This modified approach also brought to our attention the importance of internal engagement within the city and how long this can take, leading to a new section on stakeholder recruitment being added to the beginning of the protocol. So Gary tested the protocol on a public park and athletic complex, and Evanston tested it on a public library, for example. Okay, so what were the outcomes of the project and how does the tool work? So the CRISP guides the municipality through a step-by-step process to secure vulnerable infrastructure using existing information and city planning services. There are 5 steps. First, assembling a CRISP team, then gathering relevant information on hazards and climate data, identifying municipal infrastructure, facilities, or sites in extreme weather hazard zones, then performing the simplified vulnerability assessment on those facilities of most interest, and finally determining actions to mitigate or adapt to the identified vulnerabilities. So the CRISP package can be found on the City Initiative's website, and I've included a link on the last slide of this presentation. And the package includes several components to guide the city through this process. The first is a 4-page short guide that gives a quick overview of the tool and the steps involved to help a city decide if CRISP is right for them. It includes basic information and a number of resources to help a city get started. This includes a list of possible facilities and strategic sites shown on this slide. So some examples can include water treatment plants, electric power generation facilities, or cultural heritage sites, for example. And the short guide also includes a list of where to find climate information at the state and national level, shown here, and a list of local resources that most cities should have access to, like local emergency management plans and floodplain data. So the beef of the protocol is described in the technical guide and risk matrix. The guide includes a detailed description of climate change impacts for the Great Lakes region, taken from data sources that are intended for a general audience, like the National Climate Assessment. So for the Great Lakes region, a major concern is a predicted increase in extreme precipitation events and resultant flooding. So the focus for most of these pilots that I'm going to talk about was extreme precipitation events. It's important to note that CRISP does not require any modeling and that the climate data needed should be familiar to most city decision makers. So the technical guide walks you through the step-by-step process from start to finish. And the screenshot on this and the next slide give you a feel for the content and the look of the matrix. There are 6 sections, starting with general information and working through identifying risk areas, risks from other hazards, immediate hazards and event response capability, site-specific flood components, and finally, a risk to strategic sites. So in each category, the hazard or risk element is in the left column, and the city's CRISP team completes the right column. Suggested mitigation measures are pre-populated in the right column to guide the process, although these are only suggestions. So the matrix walks the team through a set of evaluative questions for individual facilities that can be answered with existing data and experience. And here's an example of section C, identifying risk from other hazards. And we have 2 questions on the particular infrastructure's vulnerability to high winds and extreme heat. So in addition, the project white paper, which is available on GLEAS's website and the City Initiative's website, describes the project process in great detail, describing challenges and lessons learned. Additional resources include a PowerPoint presentation and webinar recording, and a list of short and long-term adaptation measures. The entire exercise is designed to be completed in just a few 2-hour sessions or a dedicated 1 to 2 day workshop. Although the preparation to gather the climate data and to assemble the team itself does take considerable time by the project leader. So I'd like to spend a minute or two on some lessons learned for those of you interested in either undertaking a similar project or perhaps using the CRISP tool in your community. So first, we found project flexibility a key to be able to respond to feedback from the stakeholders in the cities. As I already mentioned, the project timeline was shifted to conduct the pilots in 2 phases, with Gary going first and the advisory cities following. We also expanded the scope of the project beyond infrastructure to include sensitive sites, and this was at the request of Gary, so to include cultural heritage sites, wetlands, or Superfund sites. Next, we saw that integrating climate information into existing planning processes was very attractive to the cities. Both municipal staff and city leadership were big fans of this. This allowed the project teams to leverage existing budget lines and to get buy-in across the board. So while projects like these often have 1 or 2 strong champions in the city, having broad buy-in ensures that the identified actions will be implemented even if there are staff transitions. We also learned the many benefits of interdepartmental collaboration, allowing stakeholders to have conversations that don't often talk to each other in different city departments. And our understanding is these relationships have continued since the project ceased. One interesting outcome from this for Gary were positive opportunities. CRISP was designed mainly to focus on avoiding negative outcomes, so property damage or loss in productivity. But Gary decision makers from different departments worked together to identify vacant and abandoned properties that can be used to build green infrastructure, to both increase their city's resilience to these events and to revitalize their community. Finally, we heard at the end of the project that CRISP would benefit from an accompanying technology platform or some kind of tool to better organize the data. And since this project has generated so much interest, we're in the process of finalizing a standalone risk matrix in a fillable PDF format. This will soon be available on GLESA's and the City Initiative's website to partially address this issue. So as a result of this project, the City of Gary, Indiana, identified and classified the vulnerability of critical infrastructure and sites in their city. As a result, they integrated this process into the ongoing hazard mitigation efforts since the 2008 flood, and the city's annual capital investment planning now includes infrastructure improvement based on its climate vulnerability. And here we have a quote from the city's director of Green Urbanism and Environmental Affairs, noting how the protocol is valuable. And Brenda states that the CRISP puts municipal staff in the driver's seat, helping them to understand how extreme weather could affect the operations of their facility or infrastructure. By drawing directly on staff knowledge and experience, the CRISP helped me secure staff buy-in and build a shared sense of responsibility for the next storm. So continuing on informed decision-making, the city of Evanston, Illinois, learned through the process that the backup generator in their library was in the basement and was vulnerable to flooding. It was replaced and relocated at the recommendation of the CRISP project team. And in many of these cases, the facilities being looked at by the cities often serve as shelters or safe areas in these storms. So it's very important to make sure that important services like electricity can be maintained. So since the project finished, the city's initiative has done considerable communication and dissemination at local meetings. The package is on its website and they continue outreach. So we've seen how Gary and Evanston applied CRISP, but how can it be used more broadly? So the protocol was developed from the start to be transferable to any small and mid-sized city. However, the climate information in the technical guide and the questions in the matrix are targeted to the specific projected climate impacts to the Great Lakes region, like increases in extreme precipitation. But many, if not all, of the questions are relevant to other locations, Some additional ones just may need to be added. As I showed earlier, the CRISP short guide includes a list of publicly available climate data sources that can be used to execute the tool. And while CRISP does not require tailored climate data, support from a boundary organization like ERISA can be helpful to distill and interpret this information. So if any attendees today are looking for a boundary organization or climate service provider in your area, please let me know, and I'd be happy to work with you and my colleagues to find a possible partner and facilitate an introduction. So that said, I wanted to end with some thoughts on how CRISP may be updated to apply to broader areas outside the Great Lakes. So expanding the protocol to the national scale could include adding projected climate and weather impacts for other regions, perhaps from the forthcoming 4th National Climate Assessment due to be finalized next year, as well as a list of national possible partners and funding sources, either to support using the CRISP itself or to fund implementation actions to address identified vulnerabilities. As I mentioned, we are finalizing a fillable PDF version of the risk matrix in response to this project, generating a good amount of interest and knowing that a template would be helpful. And finally, we are talking to the city's initiative about new ways to continue to promote this tool at the national scale. One idea is the Urban Sustainability Directors Network. So I will end there. You can see here the link for GLISA's website and the city's initiative, and you can find the CRISP tool on both of those websites.
Thank you very much, Jenna. That was terrific. I'm going to go ahead and introduce Kirstin now, but if people want to start typing questions for Jenna, we'll read them after Kirstin's presentation. So next up is Dr. Kirstin Dow. She's a professor of geography, earning her Ph.D. from Clark University. She joined the University of South Carolina faculty in 1996. She's a social environmental geographer focusing on understanding climate impact, vulnerability, and adaptation. Kirstin was recently named as a fellow to the 2016 inaugural class of AAAS Leshner Leadership Institute Public Engagement with Science and Breakthrough Leadership Scholar by the University of South Carolina. She serves as a principal investigator of one of our RISAs, which is the Carolinas Integrated Sciences and Assessments, partnering with decision makers to bridge climate science and decision making in support of climate adaptation. She is a co-editor of Climate in Context, Science and Society Partnering for Adaptation, Wiley 2016, a volume focused on the 20 years of lessons garnered by RISA teams. She was a lead author on the Intergovernmental Panel on Climate Change Fifth Assessments Working Group 2 report and an author on the IPCC Summary for Policymakers. She currently serves on the Climate Working Group supporting NOAA's Science Advisory Committee and is a lead author on the Southeast chapter of the 4th U.S. National Climate Assessment. Okay, Kirstin, it's all yours.
Hi, I need to edit that. Thanks everyone for joining me. I'm going to work at a little different scale than Jenna did and introduce a process that we use at CISA for vulnerability assessment. It's been a joint effort done in collaboration with Jess Whitehead, who's now at North Carolina Sea Grant, Seth Tuller and Tom Webler, who are at the Social Environmental Research Institute in Massachusetts. So let me tell you a little bit about it. So we're interested in the challenge of producing a decision support tool that addresses many of the same concerns Jenna did, looking at adopting risk-based approaches, integrating natural science, hands-on working with decision makers to help them make sense of maps and models, and doing a local assessment that engages stakeholders in identifying the risks and the strategies that they're interested in. Where we fit in this whole process of adaptive management, I think this process really just has a small role in it. It's documenting threats, analyzing vulnerabilities, and thinking about what those actions are. I'll tell you a little bit more about how we get there. This is a summary table from a paper by Kettle et al., I think it's 2014, that talks about why it is that we need to combine these types of information, because the sea level rise and rainfall estimates are somewhat decontextualized, but similar to what Jen is doing, we're interested in knowledge about the local hydrology, we're interested in understanding personalities and bylaws, and thinking about some of the other dimensions that go towards identifying viable adaptation strategies. One of the really important pieces here is getting at these issues of what people think is important in the local area, because the experience from working on technological hazards and other hazards in the past has been that often the experts and the public disagree on what's the most important risk and what is it that they're trying to work on and conserve. So this process is somewhat in response to those lessons learned, that we really need to make sure that we're on the same page on what the problem is that we're trying to solve as we move forward in adaptation. So what we're doing is helping structure discussions using a conceptual framework approach, a concept mapping tool, really. In the context of an analytic deliberative process that's facilitated, we use a causal structure of hazards that begins with the threat and then looks at the consequences and outcomes. I'll show you in a second, with the idea being that if you can if you can develop a chain of what the issues are that lead to the development of a hazard, you can identify different vulnerabilities and opportunities for intervention at different points in that chain of interactions that lead to a hazard. And we also use the vulnerability language, although we use the vulnerability concepts, but not the language, because the jargon just confuses people, is what we found. So I'll show you some of these pictures in a second. We've done some of the take-home lessons that we've had as well, is that it's important to be flexible on time demand. So breaking it down into a 2-day, similar again to lessons from Jenna, thinking about doing it in 2-hour blocks, doing it in a short 2 days, it has been important to people. And the goal is really to produce the information that's most relevant for people in decisions, constructing scenarios about what future risks might be. And it opens the door to identifying local complexities and uncertainties, and often it identifies questions that need to be researched or investigated to understand what the vulnerability or opportunities really are. So the basic workflow of doing one of these is to prepare. So you work with a partner organization, and we've worked with 15 different communities, North, South Carolina, Florida, Massachusetts, Maine, as a group, and found a key contact who's helped us identify key people to bring in, to talk with about what the process should look like to suit their community. So is it 2-hour blocks? Is it 2 days? Is it a discussion among community leaders and key staff, and then followed by a public process? Or what are the ways that you bring the information together and then validate it in broader settings are all possible. So you negotiate that, talk to people about what the key concerns are, so that you've done some background work and you know what information you need to bring to the table. Again, as Jenna, you're a great lead-in for me. It takes a little work to be ready to answer the kinds of questions and anticipate it. And then we have meetings where we'll develop a diagram, and I'll show you, like I said, I'll show you that in a minute. We'll sort of meet, capture the ideas, and then get some feedback on it, and meet again, refine the diagram, and then report out, sort of do a summary of what's in there, and have that reviewed. And then what we've been doing lately is working on evaluation to see how it is used by communities over time. Oops. So I went to the very end. I apologize. I hit end instead of page down. And here we are. So so we get somebody like Jess Whitehead here, our partner, talking about facilitating this. It does take a knowledgeable facilitator, and it's often good to have someone who knows the climate science to speak to the climate science in the discussion and raise questions as you go along. So we're asking about what are the hazards in the community, why do you care, what are the results you're worried about. So if it's not just worried about standing water, we're worried about standing water next to roads and undercutting that kind of infrastructure. You need to bring that information out. And we want to hear about, this is our vulnerability question. What makes impacts larger, better, smaller, worse? Are there sensitivities in the community that they're aware of that might be part of this? And then how do we imagine it might be prevented or mitigated? Some of that information coming from people with a scientific background, throwing out ideas, and people with a lot of local knowledge reflecting on those and maybe generating some new ideas. So it looks a little bit like this. What are you worried about managing? Is it stormwater, beachfront erosion, whatever? What's the threat you're interested in? What are there any things you can do to reduce the hazard itself? Public actions, private actions. If you're worried about extreme rainfall and a flooding hazard, well, then you can start to think about a lot of things that are sort of upstream to protect or reduce that hazard. But then you can also say, well, that the flooding is going to cause a number of different issues. What can we do to reduce those kinds of things? And what can we do to mitigate consequences once we get there? And what we call contextual factors here are all the things that we might think of as vulnerability. So quickly, so we do this, we just start simply say, okay, what are we trying to manage, and what are the things that we know about in climate that might make that more complicated for you? And the conversation starts. You say, okay, that's we got it connected, we got an outcome that follows that kind of hazard, and we end up with a diagram. Here you go, finally. It looks a little bit like this, saying we're worried about our stormwater and heavy precipitation. We know that we can manage it with infrastructure, but we're also worried about organic waste in the stormwater, and what are the issues with having that enter the waterway, the potential that could exceed regulatory standards. Will the town be fined for noncompliance? Is that going to, are they going to tax the town's reserves and so on? So you say, these kinds of decisions have broader implications, and playing that out often helps people understand why we're so worried about the type and extent of drainage infrastructure. That contextualizes it further by going through the entire chain and giving really the whys. This is just one example. There are many others that people have followed. So I'll give you a couple of real examples. This comes from Beaufort, South Carolina. They have a major problem with rainfall, development, stormwater management. They're in what we call in South Carolina the low country. So if you see the map of the mean high water sea level rise of 1/2 foot is the area in blue, and then you've got progressively more concerns with that. But it doesn't take a lot of water to cause trouble in Beaufort County, and they were interested in identifying causeways, school transportation routes, and thinking about disclosure under the county real estate disclosure. And the relationship with the county is one of the things that came out, is who has jurisdiction over these issues and how are they going to work to collaborate. In this case, it was a set of Beaufort County staff and public officials who did some initial work that was then vetted by public workshops. And they came up with a big diagram like this, but if you pull it out, it's, we're concerned about wildlife habitat, we're concerned about runoff into ponds. What does that mean for outflow? What does that mean for our shellfish? Are there going to be impacts to shellfish, people who are fishing, so on? And then some of these others, like there's a harmful algal bloom issue that they might not have been aware of, We haven't seen it yet in South Carolina, but we're not going to forget that that might be something coming along. Similarly, here's this one sort of raises these questions about, well, what does it mean to have reduced property value, and what are the feedbacks, and where are the interventions if we find that the threat of land loss and fear of property loss creates additional concerns. So, okay, walk it through. What are the steps here? Where are the possibilities to change this and intervene at each step? And that means people have lots of options. If one isn't going to work for them, they can go to another. Last example here is from Folly Beach. In this case, they used a survey to collect information on concerns prior to the meeting, and then they followed up with a priority setting system to rank recommendations at a public workshop. So it was staff from Folly Beach, some state level staff who were specialists in coastal management, and then a priority setting system. And it resulted in this report that's been accepted by City Council, and they're working on it. So some of the things that they wouldn't have necessarily thought of and hadn't been thinking about until they started to put these stories together is septic vulnerability. They have septic systems on the island. They're not well maintained, and they're not particularly closely monitored. So thinking about that led to an immediate action of just figuring out how big that problem is. It was the first thing they did there. Thinking about their drainage management and their marsh front. It's an island with a beautiful beach that gets a lot of attention and a lot of money because it's erosion prone, but they hadn't paid the same amount of attention to the marsh, where they don't, for instance, have rules about can you harden the shoreline or other kinds of things, and where they do have issues with stormwater infrastructure backing up and bringing salt water into people's homes and onto the roads. So this is a set of 10 different things. A lot of concern for us about the policy issues of coordination between government and agencies. Didn't make it very high, but it comes up very, I'll pull it out because it's so consistent in the kinds of conversations we have. All right, so just to pull out a little bit more about this example of thinking about the vulnerability of the septic systems. This comes from their report. I just pulled out a few examples of what the community is saying. Well, they already are worried about what the water quality and human health concerns are. Are they worried, when you have 3 feet of sea level rise? So, how are they going to address this issue? And for the political issue about balance of septic and sewer, and the concern is if treatment is put out, then that will allow for unfettered development. There's some argument that, and people are disagreeing about that, facilitating the island would lead to other concerns. But it's out there. They're going to have a public debate about it. Some of debating about risk is just working through these levels of concerns. And then also these ideas that we've got, we're already observing lots that don't drain well and are not being developed. Some of the solutions here that they're offering are, first, kind of basic steps to doing a better job. Maybe a CRISP approach would be appropriate to doing the mapping, thinking about what they've got for septic tanks, the failures, the age of the systems, and really doing an inventory to know what the scale of issue is. Doing some vulnerability assessment with an engineering firm. Having a discussion about the pros and cons of the sewage system expansion, thinking about priority areas where you would want to do extending, and thinking about the implications for managing the revenue. What are the benefits and costs to the city? So it raises economic issues, it raises physical risk issue, it raises perception issues, and then it also raises things like, well, about now we should start paying attention to maybe monitoring the septic systems a little more regularly, and not just at the time when houses are sold. So, and they wanted to start with the rental properties, but because they've been known to have some real problems. So it does raise a number of opportunities at different stages. And there's a little diagram that shows same sort of thing, just linking the ideas together. And you can also see some ancillary benefits through some solutions. Now, so what we learn about this process of doing a diagram with people, saying, what's the hazard? What next? What next? What else? What matters? Is that it helps local planners out because they're often interested in talking about hazards, but traditionally it's just a topic that's hard to get people in the room for sometimes. It just doesn't generate that much community engagement, but you want people engaged. So it's been that's been a challenge, and this process helps in that area. It's important, and sometimes the value of this depends on getting the right people in the room or developing the right vetting process so that you actually do bring different areas of planning and knowledge together, and people learn from one another and appreciate that. So it supports a understanding and information sharing, and the self-generated scenarios and issues of consequences become more credible to people in the community. So we talked that through, and we're doing some risk assessment as we're talking that through. Some evaluation has suggested that people really like the part where we thinking about solutions along the way, and both the public and the private solutions, so that there's a diversity of strategies that'll be available for discussion. And I wanted to identify the last one because working with the RISAs and being interested in the co-production of understanding of different issues to solve decisions, you could often find that interesting questions come up in these types of dialogues. So one, an example from Nags Head, North Carolina, where Jess Whitehead and Lisa Shivanato have been working, was what are the rules for deciding that you're no longer going to maintain certain stretches of road or infrastructure provision? And it turns out that there's a lot of policy research that goes into the separate sets of regulations that govern each of those decisions. Quickly for next steps, what we're going to do is, we're going back to communities and asking what they've done over time. We know that Folly Beach had their city council approve that report. We know Beaufort's integrated it into their comprehensive plan. We'd like to go back to some of the other communities we haven't been in touch with as often, or haven't done something published that's as easy to keep up with, and ask them what had staying power with them and how they used it. But we're also interested in the social learning process. So a lot of, often people talk about social learning, but it's individuals learning in a social setting, but we're interested in the kinds of cultural tools, societally produced tools that people are learning about and how they value them. So different ways of thinking about what the system is that we're interested in. So you get that concept diagram. Different understandings about what the societal context is for the problem. There's been a long debate about septic versus sewer in Folly Beach. It's important to sort of recognize that and thinking about moving forward with adaptation. Forms of expression, ways of making sense of complex problems. Some of these are, and we're interested because a lot of times we're putting forward a good deal of scientific knowledge, but there are other skill sets and types of learning that people value, and we want to learn more about what those skill sets are and think in a broader way about what types of learning we try to foster through the deliberative process. We've done, the case studies that we've done are summarized at this website. It also includes a guidebook that has a lot more detail on the facilitation and the software we use and examples and so on. So there's quite a few additional resources. And I'm happy to talk with people, and of course, Jess Whitehead, Seth Tuller, Tom Webler, Liz Fly, lots of people who've worked with us on this and participated in training, have thoughts about how to go forward and continue to refine and tweak and customize the process. And that's what I got.
Thank you very much. That was great. Yes, go ahead and send back the. Oh, you can do it. Right? Yeah. Okay, we're going to send it back. Go ahead and type in any questions you may have for our two speakers. In the interim, I really want to thank both of them. It was quite informative. And while we're doing this technical stuff, I just want, for those on the phone, if this is your first time, because some of you may have heard this through at least my listserv, this is a series that we started within the office, within OER, within NOAA, and, oh, thank you. Sorry, and just that we started, and this is, we do it roughly quarterly, and each of the different parts of the office take turns doing it, and this happened to be the kind of program office, and we featured mainly the RISAs and COCA, but we've had other ones where we've had Sea Grant, and we have the Office of Water and Air Quality. So if you're interested in learning more about this particular series, I'm trying to get there, you can contact one of us as soon as I can get the page going. Maybe not. Well,
while you do that, why don't I read some of the questions?
Yeah, so now we're going to go ahead and get some questions, and we'll go from there.
All right. This is Elizabeth Boring from Sea Grant. So far, we have a couple comments and a question. John Wiener, if I'm saying your name wrong, my apologies, said, thank you. This was for Jenna's presentation, by the way. Thank you. Please consider contacting American Society of Adaptation Professionals and ACCO and APA Hazards Group to seek comment and dissemination. Still on a field guide to adaptation mitigation tools. So, Jenna, we will make sure that you get this. And John, if you can clarify what ACCO and APA are, that would be great so the rest of us understand. And then
APA is American Planning Association.
American Planning Association, awesome.
And it's an association with climate change officers.
Okay, great. Well, you guys know it?
Yeah.
Perfect. We had something from Stu Schwartz. Stu, I'm not sure if this is for Jenna or Kirstin, but I'll read it. And actually what I can do is quickly unmute you, Stu, and you can actually ask it yourself. So, Stu, can you talk now?
Sure. Can you hear me okay?
Yes, thank you.
Thanks. Well, I guess the gist of the question is, in the second presentation really started by emphasizing the importance of identifying from stakeholders the things that are really important to them, the values and the critical outcomes and so on. And my general question is, this is something we've been trying to do across disciplines between stakeholders and atmospheric scientists and hydrologists and so on for many years in the climate change program. My question is, how do you get beyond the nominal response that you always get from users? And the example that we've seen so many times is when someone asks water resource managers what's important to them. The social scientists doing the interviews always come back and say, water resource managers consistently say they need more accurate forecasts, but we've never had much skill in closing the gap in what that really means and distinguishing accuracy the way atmospheric scientists think of it in terms of their statistical skill in atmospheric models, the operational skill that really matters to water resource managers, and for many of the social scientists conducting these interviews in between, the cross-disciplinary use of common vocabulary with very different meanings makes it really tough to know that you're actually identifying, if you will, the true values rather than just the nominal values. Because when you ask these questions in a survey, you always get an answer, but how do you get to the real operational value as opposed to the nominal value? Maybe that's the best way to describe it, if that makes sense to you.
Thank you, Stu. So, Kirstin, do you wanna address that?
Sure. We sometimes with this, we're really not getting at this level to the distinct operational value. That it sort of depends on who's there. But on the other hand, we know, for instance, in some cases we had the guy in charge of the sewer system, and he could tell you exactly why he was concerned, how much rainfall he was concerned about, for instance. And we could, because we had rainfall at high tide, potential for inundation was and infiltration into the sewage system was a major issue. And we could sort of talk to him about what we could and couldn't say about what he needed from a forecast, and think about and direct him maybe to different resources based on the science. In other cases, we can say, well, if you really, we can show you what are the issues. We may have to do some additional research to identify particularly what what elevations of sea level rise you're interested in. We haven't got, I've worked with water resource managers. In these community discussions, I haven't come to that kind of engineering issue that has the same sort of emphasis on local numbers that that you're describing. We've that just hasn't been a major part of what I remember in many of these discussions. Ranges of values have been okay for this in a dialogue setting.
All right.
I can't give you, maybe Jenna's got a better answer.
Jenna, go ahead if you'd like to.
I think Kirstin handled it better than I could.
Okay, we don't have any other questions. If you have them or you're furiously typing, please, go ahead, and we'll wait a couple of minutes. We still have 10 minutes before we're going to be done, so we have some time. And I'd like to reiterate Nancy's gratitude. So Kirstin and Jenna, thank you so much. And thanks to everybody who has joined us. We are recording this, and we will send out a link to where the recording is for your colleagues who may not have been able to make it.
Well, thank you very much. It appears that everyone was satisfied with both presentations. We will post this on a website, which will send you the address once it's posted. And we want to thank both speakers today for participating. And if you have any questions, I'm going to go ahead and take the liberty of telling you, you can go ahead and contact them directly. Both of them work within the RISA, the Regional Integrated Science and Assessment, and they should be easy to find. And if not, you can contact one of us, and we will put you in touch with them. So thank you very much, and have a good evening.
Thanks, everyone. Thank you for organizing this. Bye.
Thank you.